the medicine that cures you, the design of your phone, and the curiosity that asks why and how. It is the foundation of innovation in everything. This year's theme is Women in Science, catalyzing Bikshit Bharat. Reminds us that every student of this renowned girls' college, regardless of their stream, can contribute to building a better, sustainable future through critical thinking and informed decisions. So today, I urge all of you to look beyond the textbook. Let's celebrate the spirit of inquiry, the joy of discovery, and the power of knowledge. Let's make science a way of life. Thank you. So today's day will start with the movie to Sir C.V. by screening a documentary on his life and work. This was actually developed by Workshop. So it will be like a half an hour documentary, so we will start with the day. And later on we will have our respected speaker. He has already arrived, Dr. Tamal Basak. So we will have the next section now. Distinguished guests and dear students and my honored faculty members, we are here to celebrate the National Science Day 2026. So, first of all, I would like to call the Principal Ma'am on the stage and have a seat. Respected Principal Ma'am, please come up on the stage. Then I would request our distinguished guest speaker, Dr. Tamal Basak, to take the seat. Welcome, sir.
to deliver the welcome speech and formally inaugurate the session.
Thank you, Dr. Sir. Very good morning. Good morning and regards to today's speaker, my dear colleague and students. Innovation Cell, in association with Institutional Innovation Council, is organizing or is celebrating the Science Day 2026. Why particular day is celebrated? I urge the students, please think you individually why particular days are celebrating. Our motto to inculcate the interest among the students. Each and every day, from morning to night till the sleep, we are using science, but we are neglecting science. Without science, no human being will exist. Because at every discovery, there is a contribution, or first contribution is science, from science. But nowadays, especially among the students, there is a lack of interest towards especially towards the basic science. There is a trend now to study engineering or other course which we are saying as a professional course, but we never think science itself is a professional course. In the science, if you read, if you study in any stream, there are enormous scope.
Prior to this, he was an assistant professor at NEP University, Kolkata, where he contributed significantly to academic and research excellence. He began his academic journey with an MSc in physics from the prestigious Presidency College, Kolkata. Driven by a deep curiosity about the mysteries of space and atmospheric science, he pursued his PhD at the renowned SNO's National Center for Basic Sciences, Kolkata. His doctoral research focused on sub-ionospheric radio signal propagation effects, a crucial area in understanding space, weather, interactions and their impact on communication system. In recognition of his outstanding contribution to radio science, Dr. Basak was honored with URSI Young Indian Radio Scientist Award at the Excellence and Dedication in the field of space science, physics. Expanding his research horizons internationally, he served as a postdoctoral researcher at the University of Electrocommunications, Japan, where he engaged in advanced research and global scientific collaborations. Dr. Basak has authored numerous research papers published in internationally peer-reviewed journals and has presented his work at prestigious international conferences across USA, Japan, Germany, UAE, Portugal and Turkey. His global academic presence reflects not only his scholarly depth but also his commitment to advancing scientific knowledge beyond borders. Today, as we celebrate the National Science Day, a day that honors the scientific spirit, inquiry and innovation, we are privileged to have with us a scientist who embodies these very ideals. So without much delay, I would request Dr. Basak, please come up on the stage and start your speech. Thank you, sir.
And my dear students, today we have gathered to push to promote innovation and scientific thinking. Now, the theme of this year's National Science Day is Women in Science. Women in Science catalyzing Vikshit Bharat 2026. So, this perfectly aligns with the commitment of our institution in empowering women. So, we are grateful to our principal madam, under whose guidance we are able to host these programs. And we are honored that Dr. Basak will share his thoughts with us today and enable our students to understand how to pursue a career in space science. Thank you.
Thank you very much for your motivating words and guidance. Thank you very much. Now,
in developing the nation. From the discovery of plant life to the frontiers of quantum statics, Bengal has been the cradle of India's history. We aren't just talking about history, we are talking about the pioneers who built the infrastructure of our self-reliant modern scientific identity.
Principal Madam, very warm welcome. Nice moment for me to be in Victoria College, a very ancient college, important college, and very respected college in Kolkata. So today I want to speak on not only about the universe and the space mission and the space exploration. I also like to speak about how you students can take the space science or the astronomy, astrophysics, space science as career. Because what I feel that students are most of the time they are confused that how to get not only to listen to this, not only to get fascinated to this subject, but also to get this subject, to take this subject as a part of it. That is most important. So this picture, this picture. Do any of you know this? What is this? What is this picture? It's a very famous one. Do you know this? Any idea? This is very simple. Our solar system. Okay. What we actually see that the sun is there and all the planets are moving around. So this is not the true story. The true story is that our sun itself is moving around the Milky Way galaxy, and due to the neutron's gravity, all the planets are following behind it. This is actually the real scenario of our solar system. And you will be surprised that what is the velocity of sun moving? This velocity is 250 kilometers per second, not per hour. 250 kilometers per second, sun is moving. So that is the purpose I took this picture on the first slide. Okay, so the next thing is that today not only the science day, today is in NASA they call it the planetary parade. Means that not only today, so this in media I have heard that they are saying that the planets will be visible only today. This is not true. This is actually visible for the entire month. But today is somehow marginally better, which is not visible by our, you cannot differentiate it with our naked eye. But this is a true story. If this is a picture taken from stellarium, but this picture is from at around, if you see, look at the sky at 6 p.m. today. So you will see this scenario. You will not see the sun because sun is already set after that, and you will not see the Mars because Mars is already ahead of sun. So Mars you will see in the early morning. This is called Shukta. You know that is called Shukta. But all the other planets, for example Jupiter, the brightest one, for last 2-3 months you will see this. We are seeing the Jupiter. Next one is the Uranus. Uranus you cannot see from Kolkata because Kolkata is polluted and dark sky. If you have very good telescope, then you can see. But just after sunset, please all the students who are present here, I request you just try to go to some rooftop and manage to go to some rooftop and look at the. Very easily you can see the Venus as well as Saturn, even from Kolkata. If you go to outside Kolkata, in a village in Nepalpur or degree of liquid, then you can see. Okay? And Jupiter is very, very bright. You see, even before sunset, you will start seeing Jupiter is so bright. Okay? Magnitude is probably -2. And magnitude is inverse. Minus means brighter objects, and plus means they are fainter objects. So I will come to that. So it's very interesting thing. Now I think just I should speak that after 56 years, our human civilization is planning to get to the moon. So that's why this is the thing. This project is called Artemis 2. Artemis 2 is going to launch. It was supposed to launch by February, this February, but it was delayed. And this is Artemis 2 mission. There are 4 of the astronauts, the Red Wiseman and for the first time, for women, for the first time in Islam going to moon. This is a very interesting thing. And not okay, but this is not a landing mission. This is called a flyby mission. They will go, they will fly by the moon and they will come back. So it's a total 10-day mission. But the most important thing is that this is they begin. You know, just yesterday, I hope you have heard in the news. Just yesterday, Artemis 2, the space vehicle is called SLS. Space launching system, that is again back to back, and it's called the vehicle assembly building. Just because they have a problem in the helium fueling system. It's a small leakage. Small leakage is how small? It is of the order of size, of the order of microns. Doesn't matter. But as I written as safety first, and in the micron order system, leakage cannot be allowed when you are going to or taking something to space. That's very interesting. But of course, I think hopefully maybe in April, the people they will be going to moon again after 56 years. And this is very interesting. This is I hope many of you don't know. Maybe know that this one is a virtual boarding pass. NASA is issuing to all people, and they are just you will see your name is happy available there. But why it is interesting? Just because they are taking a memory chip with them to the spacecraft just around the moon, and the memory chip will contain all the names who will have it before. Already, already 1.5 million people have already registered. That is the interesting thing that you will be happy that your name will just fly by the moon, at least for within your life. That is the happiest thing. You can do this. This is just when you return it, you can do it. Just to show you. However, let us come to this interesting thing that what is astronomy? As first, but that astronomy is one of the oldest subjects in science, and people did not start astronomy just for learning. That okay, day one we start learning astronomy. It was not like that, because when people did not know that why there is the sky, the stars are twinkling, or why there is rain, why there is earthquake. By the way, the earthquake is in the no time it was very strong. It was in Bangladesh, only 100 kilometers east of Kolkata. So at that time I was talking about almost 6,000 years ago. Then people did not know why these things. Now we are very happy that we know that what is happening. Sorry. So people that time people did not know why these things are happening, why the stars are twinkling, why the rays of light they are called comets. At that time, out of fear, out of surprise, out of curiosity, they started learning something that, and going by the time, this subject became astronomy. This is the history of the birth of subject called astronomy. And this is a very famous picture, the Dept. Dept is a very famous Greek mathematician. He was actually born 200 BC, and in his hand, his device, it was called sextant. I hope you have heard of this, the sextant. At that time, there was no telescope, nothing. But he discovered the position of the sky, the basic of trigonometry and all that. So he is one of the earliest pioneers of that subject. So that is the way that the subject was started developing. But nowadays we are in a very advanced stage. We are having not only we are looking at the sky, we are going to the space, and not only the other countries, other advanced countries, but our country, of space science. So students who are sitting here, they are actually more fortunate than us, because when you will grow up, when you will plan to take up the career, you start the career, professional career, that time the astronomy subject called astronomy and space science will take a bigger and greater shape. Because not only to listening to me or anybody, you can seriously think of starting this as a career. And not only, for example, that respected principal has said, basic science, not only basic science, technology, computer, even artificial intelligence. If you have any kind of expertise, for example, if you doesn't belong to science, if you are to arts or law and management, then even you can contribute to space science. So that is the part. By the time during my presentation, I also emphasize that. So just to have a look, these are the small telescope, only a small 5-inch or 8-inch reflecting telescope. But nowadays, these are the biggest telescopes that the human civilization is looking at the space. First of all, you know the Hubble Space Telescope. You already heard about that. Then the JWST is called the James Webb Space Telescope. It was launched 5-6 years ago, and it is now it is the most advanced space-based telescope. So I request you to go to internet and check. There are many websites where the Hubble take the image, for example, Crab Nebula, Eagle Nebula, and the same image taken by this JWST. The quality has gone up 1,000 times. So you please go to that. Everybody has smartphone, everybody is going to checking internet and social media all the time. So I request this is a great media, that great time that we have internet in our hand. So use it to learn this subject. That is the main purpose of my presentation. Also, and this is a TMT. TMT is called 30-meter telescope. 30 meter is the diameter of the lens. Remember, 30 meter is how much? Can you imagine? 30 meter is roughly 12-story building. So that much long telescope is going to install in Hawaii. And why I am telling you? Because India is one of the stakeholders of TMT. India is already, but it's not to be commented yet. Probably in 2030 or 2032, it will be there to look at the sky. It is the largest, most advanced ground-based space telescope. Now let us, before going further, let us try to understand what is the basic structure of our universe. So just look at this on the this part. This is our very famous solar system. And why it is light hours? Light hours because light can travel from one end to another of our solar system in few hours. For example, from Pluto, light takes 4 to 4.5 hours to come. And do you know how much time required for light to come from sun to us? Any idea? Anybody? It's a very famous number. You must remember. Everyone, no matter you are from science or not. Do you know this number? It is only 8.25 minutes. So when you are looking at the sun, that means it is not instant. It is already 8.25 minutes history of sun you are looking at. And how the sun is looking right now, you have to wait for 8.25 minutes for that. Okay? So this is the light hour. So in light hours, you can see our solar system. Next is this is the famous picture, it's not real picture, however, this is called our Milky Way galaxy. In Bengali or Hindi we call it Akash Ganga. And what is the size of it? From this end to this end, you will be surprised to know light will take 100,000 years from one to just cross the diameter. Forget about the rest of the universe. Forget about other galaxies. Only our galaxy, our Milky Way galaxy. Or have you heard of Andromeda galaxy? Andromeda is our nearest neighbor. So the point is that only from our galactic diameter, light travels in 100,000 years. So our universe is this big. Next is this is called the cluster of galaxies. One short of light is not a star. It is individual galaxies. And they are actually light takes millions of light years. light years is called the observable universe. What is observable universe? You can ask me one very famous question: how big our universe is? Okay, the idea is that that is not an important question. How big our universe is? The important question is that how big our observable universe is. What do you mean by observable? Means the farthest extent of the part of the universe we can see, or at least we can try to see. Why? Because beyond that, all the objects, they are moving from us relatively, because you know even how the scroll of the space is expanding. You know this thing, the space is expanding. So beyond that, the things are expanding almost at the speed of light. So light cannot come from there to us. So there is no way we can observe them, or we can look at them, or we can do research on them. Is it clear? So this is that is a picture called observable universe. And in observable universe, so far, people have estimated there is 2 trillion number of such galaxies. 2 trillion number of galaxies only in the observable part of the universe. If you ask me then how much is the total number of galaxies are there, the answer is we don't know. And next is now let us come back to our galaxy. In our galaxy, they have 200 to 300 billion such stars like our sun. Only our galaxy. Or let us take Andromeda galaxy, which is almost a twin to our galaxy. They have 200 billion stars. Each of them most of them actually are bigger in size than our sun. Our sun is very ordinary fellow. They have no speciality in terms of its mass or volume or temperature. That is that. This is not like a space science or astronomy lesson or cosmology lesson. It's a lesson to life. What I feel that whatever we do, whatever we have tried of in the scale of the universe, forget about the universe, in the scale of the galaxy, in the scale of the solar system, we are nothing. Whatever we are doing, we are nothing. Just think about Voyager. Voyager is traveling for more than 50 years, and Voyager has traveled. It is already out of the range of our solar system. It is in the intergalactic plane. However, it is only at present day, it is only at a distance of 1 light day. After traveling for 50 years with approximate velocity of 50,000 kilometers per hour, students think of the number. Okay, so and it has till date, it has traveled only a distance of light day. So we cannot even physically think of traveling light. So that is so insignificant, immaterial we are. And so we have to be very polite. This is a lesson of life, so far I think. Okay. So that is the point. We see the galaxies as they were in the past, as well as just forget about everything, forget about interesting facts, just look at the night sky. When you are looking at students, please be excited. When you are looking at the night sky, you are looking back in time. You don't have to have a customized time machine. You don't have to discover a time machine or anything. Just when you are looking at the night sky, you are actually looking back in time. When you are looking at the constellations, you are looking back in time. Even moon. When you are looking at the moon, light takes 1 second to come here from home. Little more than 1 second. So moon, which is so accessible, when you are looking at it, it is already 1 second old. And when you are looking at sun, it is already 8 minutes old. When we are looking at as I told you, the planetary parrot, all the planets are already few hours older when you are looking at it. So this is the fascinating effect of this subject. This is, all of you know, this is called Big Bang. Big Bang is a theory that most of the scientists believe that about 14 billion years ago, from nothing, please listen very carefully, from nothing, something has started. People, media and otherwise, they call it Big Bang was an explosion. It explosion. It was like starting of something from nothing. That is the fact. When it was happened, and till date, it was believed that the universe is expanding, has been expanding since Big Bang. But the fact is that universe is having some expansion, which we call accelerated expansion. Not only expanding, but it is accelerating in an accelerated manner. Today, universe is accelerating at a greater rate than before. This is the fact. So now, two very fundamental things. First is that universe has no center. That is, for example, if you have this room, that somewhere in the middle, that is the center of this room. If you ask me where is the center of our universe, there is no center. Because when Big Bang happened, before Big Bang there was so-called as nothing. So every point we are looking at is equally important. So there is no center of the universe. And the second statement, the universe is mostly dark. This is even more interesting because whatever these galaxies, as I shown you the picture, the galaxies and the nebulas, the cluster of galaxies and mega clusters, super clusters, all the visible matter, all the visible energy, if you put them together, that is the less than 5% of the existence of the universe. It looks like power product, but it is actually fact. And 27% they call it dark matter, and rest of the percent, almost I think 68-9%, this is called the dark energy. I am not going into detail, I should not go to the detail, but just 1 second. Why dark? I should tell you the difference between dark matter and dark matter. Dark matter is that which actually keeps our galaxies rotating and bound together. Because galaxies are rotating, galaxy itself a rotating object, I will show you, but this is not following, galaxy rotation is not following Kepler's law. So who is supplying the extra amount of energy? That is coming from dark. And dark energy is even much bigger thing. Dark energy keeps the universe expanding in an accelerated way. The universe is accelerated. So from where the energy is coming from? For example, if you just expand, for example, a balloon with air, so you have to put some energy. Charles law, Boyle's law, you know this. But universe itself is expanding. All the galaxies, in spite of the gravitational attraction, they are going away from each other every time, and not with the negligible velocity, very significant velocity. They are going away from. Who is providing the energy? That is called the dark energy. And why is it called dark? Dark means it's not black or lack of light, it's nothing like that. Dark means we do not know the original physics of them. We do not know the original nature. What we know they are energetic effects or gravitational effects. But basic physics, what is basic physics going on? What do they interact with electromagnetic radiation? Do they interact with like our protons and neutrons? That is not clear to us. That's why we call it dark. However, next is another very surprising statement that our universe is almost a perfect vacuum. So you will say that the universe has billions. You said that 5 minutes earlier you said that you will ask me. 5 minutes earlier you said that there are billions and trillions of galaxies and all that. Now your next slide you are saying that the universe is a perfect vacuum. So this is crazy statement. No, but why it is called vacuum? Because if we somehow manage, people have calculated, if you somehow manage to calculate the density of the universe, average density of the universe, you will be surprised to know that it is only 1-2 protons or electrons per cubic meter average density. Forget about our Earth or solar system, all that. If you take in a cosmic scale, in a cosmological scale, you take average, it is exact value I don't remember, but it is only 1, 2 or few protons per cubic meter. Do you remember? Do you know Avogadro number? Have you heard of Avogadro number? So Avogadro number is what is that? This is the density of the matter and dust. How much is Avogadro number? Now 10 to the power 23. So, okay, one funny thing is that when I ask you any astronomical number, alright, so if you ask, just tell me the order of magnitude is fine. It's 6.0 something, doesn't matter. It is, if it is, you say 10 to the power 23, so we got alright. So, this is the idea. So, 10 to the power 23 is the density around us. That measured by Avogadro. But that if you go to the universal density, it is only a few protons or few particles, few elementary particles per cubic meter. That's why we call it universe. If you assume that there is nothing in the universe, it is perfectly vacuum. Okay, so this is our structure of our galaxy. The galaxy, this is our galaxy. It is an animation image, of course, not a real one. This is an rotational time period is 250 million years, 25 koti bochor. So sun takes 250 million years to take around our galaxy. And the next picture is this is zoom version of our galactic center. Our galactic center, forget about other galaxies. Our galactic center is at 28,000 kilometers. 28,000 light years from us. When we are looking at our galactic center, you know that a few years back, Ryan and Denzel, they got Nobel Prize for discovering the supermassive black hole at our galaxy center. So that is actually 28,000 light years away from us. That is very important. Okay. Now another very interesting thing is that this is called the galactic position. Galactic position. This is animation. Okay, this is animation, but this is in reality, this is going to happen in next 4.5 billion years. In next 450 bochor, next 4.5 billion years, what is going to happen? The Andromeda galaxy is actually, due to neutron gravity, it is actually approaching us. And in next 4.5 billion, they will have a collision. But what is the funny thing about it is that the density of stars is so less in each of the galaxies that hardly any two stars will collide. This is what we are actually seeing is the gravitational disruption. But for example, we will not be there after 4. In next 100 years, we have no guarantee that we will be there. So in 4.5 billion years, forget about it. But this thing will undoubtedly happen. The two galaxies will collide and they will be disrupted and they will form a different galaxy. That will happen. But it's a real scenario. So these are, why I'm showing you, these are the funny, not funny, but these are the interesting facts. These are happening and out of our daily life. So all the students who are here, they have to start and they have to think about that these are not the stories, these are not like pictures and mythological stories, these are real things happening in our universe. That the point is that we do not care it in our daily life. That is the problem. And that's why we are very much worried about our narrow thinking and so narrow-minded problems we are busy in our life. But all these things, all these heavenly things are happening every moment around us in the universe. That's the main thing. Another fact is that this is called a supernova. Have you heard of supernova? It's very simple. Supernova, what is supernova? Supernova is called a death of a massive star. If a star, for example, our sun will not undergo supernova. Why? Because our sun is a small kind of star. After death, it will form white dwarf. But if a star, for example, if the star is 5 times massive than that of our sun, আমাদের থেকে 5 গুণ বড়, then they will undergo supernova and the outer core will blast and the inner core will form a black hole or neutron star. But outer thing will blast in this manner. And why it is important? Because during supernova, please listen very carefully. During supernova, one star can outshine the brightness of the entire galaxy. That is the idea. Why? Because why it is very famous fact? Because normally you do not know that what is happening in the for example, one galaxy is there at 10 million light years away. Okay, and your telescopes cannot find the galaxy because it is faint. is very million years away, but as soon as some supernova happens over there, suddenly they are captured by that telescope. Okay, so there is some supernova, that means that some star has died. That means there is one. So galaxies, supernova is not a very interesting fact. It is one of the detecting tools of unknown galaxies. And once a supernova happens, it stays for example, from couple of weeks to couple of months. This brightness stays and then it actually diffuses to an nebula. This happens. So this is a picture. The neutron star picture cannot be taken real picture because neutron star, which is actually millions of light years away and so small. The neutron star's diameter is only 2 to 20 kilometers. So dense. One spoonful of neutron star matter is 1 billion tons of mass. Okay, so this is again, these are a funny number, the real number. One spoonful of neutron star matter is actually a few billions of tons of mass. So dense, there is no atomic structure, only the fundamental particles. Neutron stars, so they are full of neutrons and a few protons. So this is the story. And this picture is very important. This picture, many of you have heard in the newspaper or in the TV. This was the galaxy which was discovered about 10 years ago. This is called M87 cluster. M87 is a very elliptical galaxy cluster. And at the center of M87, this is the black hole. This is not the black hole. Black hole actually you are not seeing the black hole. At the center there is one darker region where no light is coming up. Black hole stays over there. And what you are looking around, the circle of light, this is called event horizon. What is event horizon? Event horizon is the limit. Beyond that, you cannot retrieve any information. I am not going to much deeper today, but event horizon is that. If you give some information, maybe light, maybe mass, maybe information, if somehow it process, it cannot be retrieved back. That's why the center is dark. So now, what is the conclusion of this statement? Is that it is basically we are made up of star. This famous statement was quoted by Professor Raman almost 30-40 years back. He said that when a star dies and then when this nebula is diffused and when then they gradually form the protoplanetary disk or planets, those are actually from that the light comes. All the elements, whatever you are seeing in the periodic table. Have you heard of periodic table? You know this. All the how many elements are there in periodic table? 118 or 140 something. However, so now the important question is that how many of them were formed during the Big Bang? Okay, so your periodic table is full of elements, okay? So the bigger question is that how many of them were formed during the Big Bang or after the Big Bang? You will be surprised, only hydrogen and helium were only. And where these hundreds of elements came from, they all actually produced at the core of the star. Because the cores of the star are the only factory in the universe where higher order elements can be found. That's why it's important. Because our body is made up of calcium and iron, whatever. They are somehow, at some billion years back, we were at the core of our body. Every molecule of our body was in the core of any of the stars. Maybe not Sun. Sun is a second generation star. Many of earlier generation stars were there. Gradually temperature cooled down, gradually planets were formed and we were. Okay, so we are actually every part of our body, we are attached to all the stellar objects. So now let us come to this. So what I planned in this talk is that not only to discuss about this, that's how to if you want to be whatever I discussed, if you want to study those things, if you want to take this not to listen for fun, just to take them as serious career, if you want to do this, so at least the way is that if you can do, if you MSc and Masters in Physics, Chemistry, Mathematics, Astronomy, Astrophysics, Atmospheric Science, if you can do this, and there are, apart from several institutes and lot They are the pioneering research institutes. So they are IIC, IIT, IIFR are not including our Indian Center for Space Physics. Our center is the only institute in the eastern region of this country who are actually fully dedicated to astronomy and space. So these are the things. So if you are taking this subject, if you aspire to take this subject, these are your future destinations are going to be. So and of course you have to do whatever you are doing, bachelor degree in college, after degree, master degree, and then for example you have to gradually go for PhD or MTech, and after this you will go to schools. So this is your destination. Next, I come to a completely different topic. Just I jump from the universe, I jump to the space mission. Now it is very famous because in the last for 15-20 years, India is advanced. So India is becoming advanced, very advanced in this subject. So if you know that in every year we are having very famous space missions, Chandrayan, Mangalyaan, and Aditya L1, all the things. So let us first try to understand how many types of space missions are there. First of all, there are robotic missions, then human crewed missions, which are most important. That we know Raman Shukla, I hope you all will heard of. Next is for the scientific missions, and then military and communication and defense. In childhood, we used to think that all the space missions are happening for all our scientific purpose, and there is no other than exploring the universe. But that is not true. There are other purposes: human crewed and scientific and military exploration. Next point is that why space missions matter? Why we should care at all about the space missions? Because they are helping in our development. For example, weather forecasting, communication, GPS. Why do you use GPS? You know, any idea? You are actually in 24 hours you are in GPS. You are carrying a GPS receiver, namely your mobile phone with you. So those satellites have all information, every inch of your movement. That is that. So that is GPS. Then healthcare, of course, nowadays national security and defense. Also scientific discovery. And another thing, which actually I did not write here, this is called the political. So this is I should not write as a scientific person. So but to space missions, just to give the mileage to politically powerful persons. But that is also thing. But these are the basic scientific, all human related things are there. And again, I must quote everywhere I love to quote this thing that exploration is in our nature. Because again said by famous physicist Sir C.V. However, so these are NASA's some iconic missions. This is again the Dept, Voyager, and Apollo mission. Do you know? Okay, so can you tell me that students? I ask you, if you are on your browsing phone, can you tell me how many successful moon missions have done till 1960s? Or roughly my question, how many people have landed and kept their feet on moon? Can you tell me that? It's a very tricky question, very class 8 level tricky question. Can you tell me? Anyone? How many missions were there? Anyone? Now what are the Ki bolbo na tumhara? Bolo eta boltei hobe. How many? Have you heard of Neil Armstrong? Have you heard of Apollo 11? Was it the only mission to the moon? Actually, there were 6 missions. Okay? And 12 persons were landed. And another 6 persons they orbited but not landed. Okay? But those happened in between 1969 to 1972. From Apollo 11 to Apollo 17. So this is, look at this. This is the solar power empowered car. They actually drove over the lunar surface in Apollo 15 mission. This was not Neil Armstrong. Neil Armstrong did not drive a car. This is I forgot the name. This is Apollo 15 mission. Was there in 1972. They drove a car. Not only that, the picture they not only drove the car actually got damaged on the lunar surface for some time. They actually repaired on the spot some minor problem, and then again they drove it. That is strong ambition, but things cannot do. When the car actually broke down in the lunar surface, they did not do so. They repair it and they broke the car. That is the reality. Okay. So next thing is that for very Mars mission, there is not only the speed, opportunity, curiosity. It has happened during last 30 years. And most important thing is that ingenuity helicopter. Have you heard of it? It was happened 10, 12 years back. Ingenuity is a helicopter which was in the Perseverance lunar mission by now. It was almost 10, 11 years back. Why it is important? So you can say that okay, you can fly, we have atmosphere, we can fly in Earth, so we have atmosphere, we can fly in Mars as well, in Mars mission. But why it is very important? You must understand why it is important. Because the atmospheric density on Mars is less than 1% of atmospheric density in our atmosphere. Please try to understand. So this is the reality. So flying something over here and flying something over there is like a million times greater task. So that's why it is very small one. It is diameter. I think the diameter is maybe only 2 feet. 2 feet. So, but it actually flew for few minutes on the Martian atmosphere. Okay, and this is a very Mangalyaan. I will come to that. Mangalyaan, but in Mangalyaan was by ISRO, but that actually happened and was not a lander mission. It was a flyby mission. Mangalyaan was there, and it has been orbiting the Mars. Okay. So let us take a quick look of the human space flights. First was in 1961. Gathering was there. This is a real video of Yuri. This one is a real video of Yuri Gagarin when you find. Then the Valentina Tereshkova, Neil Armstrong, Rakesh Sharma in 1984, and the William Shepard, and finally our Shubham was there. Why is mentioned? Because in our Indian Center of Space Physics, we are the only organization, maybe in Kolkata or maybe in West Bengal, that two of the Indian astronauts have the present were there. They actually came, two of them came in different occasions. However, so now just to give you a glimpse that how actually these things happen. This picture was for Artemis 1. Now we are talking about Artemis 2. What is the difference between Artemis 2 and Artemis 1? Actually, there is no difference. Artemis 1 was like a robotic flight and Artemis 2 will carry human. But otherwise, they were the same. That they will actually go there and they will use the lunar gravity. Try to understand, students. What actually this Artemis 1 is doing, that actually using the lunar gravity just to travel to moon and come back. Just look at this point. What an amazing point. Just one flying object is taking the help of another flying object that will use its gravity and just to successfully complete the journey. And you will be surprised what law they are following by traveling. Do you know this, students? You know this. This is called the Kepler's law. Kepler's law 1, 2, 3. Have you heard of it? Okay. So what is the message of this? Is that so when you start studying astronomy, when you do start, the answer is that when you start learning your basic textbook on physics, chemistry and mathematics, and the same day you start learning astronomy. There is no specific occasion that you start learning from other books. The basic properties or the basic elements, basic formulas, basic concepts of all the astronomy, what our universe is governed by, those all are written in school physics book, school mathematics book, college physics book and college mathematics. So that is the most interesting thing that you should think. So all these things are complex, things are going on, but what the basic law is working behind them. It is a Newton's law and Kepler's law. So now let us have a look. This is the ISS is called the International Space Station, and Tiangong is called the Chinese Space Station. The Chinese Space Station is the Chinese monopoly, and the International Space Station is governed by NASA, and the Roscosmos is Russian Space Station. Isha is European, JAXA is Japanese, CSA is Chinese space agency. So all of them have their stakeholding in the International Space Station. But you remember that India TJ do not have any stakeholding in the International Space Station. But then in the basic question, students they keep on asking me that how come Shubhangshu Shukla went? Shubhangshu is Indian. So what actually did Shubhangshu and Indian government, they actually rented the Japanese lab in the International Space Station. And Shubhangshu actually worked in the Japanese lab. There is no place in International Space Station India can call their own. So they are worked in Japanese lab, they use Japanese instrument, and of course for everything they have paid to NASA and to respective agencies. So this is the basic thing. And Chinese also they are having similar properties. It is also flying for last 5 years, and it is also at the altitude of similar to the International Space Station, which is at, for example, at 450 kilometers above our surface. So it is there. Now I will show you a very surprising picture. So can you tell me what it is? This is not a cartoon diagram, this is a real picture. This is a real terrible picture, I should say. Can you tell me what it is? Please tell me, because this is our present day scenario. This is our present, this is our terrible future we are going to face. Any idea? Can you raise your hand? Anyone? No idea? Okay. So this is the number of satellites moving around us. The center, the poor fellow is our Earth. And this is, please don't mind, this is a real scenario. Every day, Elon Musk and his team is sending up something to space. Space is their business. This is the, how much in number? You are surprised to know the number. It is 17 to 18,000 till date. First space object went in 1957, Sputnik 1. I hope you know the Sputnik 1. And this we have already made the space around us our biggest dustbin. Why? Because now I will tell you the reason. Why? Because we call it a space race. Space race is all powerful countries. So what is now two things I should mention. First is when you are having a launching a rocket, when you are sending up a satellite, what is the biggest challenge? You will be surprised to know the biggest challenge is to avoid the space debris. There is 90% chance that they will collide with something and entire project will go in vain. That is the story. And what is the second point is that all the powerful countries they are thinking about sending something to space, but nobody is thinking seriously to take them back, which at more than 60% are not using. We are not using. They are end up of their lifetime and they are just moving around the space as garbage. And they are colliding each other. Students, I just request you go to check internet, write down space debris, and you just see what those things are there. I am not going to mention. This is a real scenario. This is a real garbage dustbin kind of scenario. This is a real picture. This is a scenario. So just at this point I tell you that if you are on vertical space science, if you don't have to really follow science, if you have, for example, LLB, like PhD, MA, IAS or management, you can actually go to this in space. It's called the Indian National Space Promotion and Organization Center. Government of India is established just to control the what is happening over space, how much satellite can be sent, how much, what is the frequency, what should be the policy. The government is thinking, at least our government is thinking very seriously. So these are the things. So that's why I kept it just after this space garbage. So because it's high time that all these administrative people they are thinking that how to not only to do science with space, not only to do business with space, but to make the space also habitable and a comfortable zone to travel. That's why this kind of thing. So students who are not at all interested in science, I think many of you here who are not at all interested in science, they can think of this kind of thing. If you are doing a law, or political science, or public policy, IAS kind of thing, you can join this kind of company, this kind of organization, and start to space. Okay. So now this comes to the history of Indian space science. So we are traveling all over the world. Now was called INCOSPA, Indian National Committee for Space Research. INCOSPA, it was discovered, it was founded by our Honorable Prime Minister, Pandit Nehru. And it was like, it's not far away. And then, ISRO was formed the same year when people went to moon in 1969. So ISRO is not a very old organization, let me tell you. But what the remarkable achievement we have done in 55, 60 years is very remarkable. That's why. Because NASA is much older agency than ours. So we should not compare their advantage. But however, this is where we come to that. In 1975 only in 1975, the Arjun first satellite, Indian-made satellite was made. At that time, we did not know how to take them to the space. So we used to take help from Soviet Union. So now, very important statement that Vikram Sarabhai actually gave, that the harness space technology for national development. Because he said that we should not be in the race to go to moon or go to Mars. We should only emphasize on how the space technology, the space mission can help the common people, the national policy. And only even he passed away many years back, but only his visions are the Indian space science visions in today. All the way our government is trying to use the space science and space technology for national development, for the development and well-being of common people. That is the mission. So these persons, this kind of persons, they are not only scientists, they are not only technologists, they are visionaries. They have actually set the path for the Indian space science, for all Indian science for another 100 years. That is very important. So all the students, you must know about all these kind of persons. These persons are our inspiration. So now, this is October 19, Rohini series. This project director was our former President Tamal, and he was there. So can you tell me one funny question? I think the students, they have not seen this one. So why in a astronomy talk, why it is a 2 rupee note? Can anyone tell me? Why this one? Can you tell me? You will notice something over there. It is the image of the Arjun and this Arjun satellite. Indian first satellite. The image was there in the 2 rupee. When we used it, we did not know, we did not notice that. This is actually the truth. That's all. It's not the stamp, but however, it's very interesting. If you have it as a historic thing in your home, you could just go back and just preserve it because it's one of the historic documents. So now, ISRO has not only created not only created the science, it created a complete new domain for who are having doing the basic science and engineering or for different job opportunities for them. Okay. So what I am trying to mention is that the space science development is not a business for any of scientists or technologists or specific communities. All the branches of science, I come to that again and again, all the branches, they have something or better to contribute to the space. Then only the space science will develop. So it is just my teacher was there last year in ISRO, just in that place where all these things were happening. It is nowadays called the UR Center in Bangalore. So I will not much detail. These are called the PSLV rockets. These are called the GSLV rockets, and these are called SSLV rockets. PSLV means they can carry a lighter amount of payload. For example, Mongol jump, all these things they have happened for PSLV rockets. And for GSLV, you know the Chandrayan 1, Chandrayan, Aditya, Aditya was in PSLV. Chandrayan 1, 2, 3, those are in PSLV. And these are called, nowadays, the latest technology is called SSLV. SSLV is called SSP, small satellite launch vehicle. The small size satellites being there or customized. Nowadays, all the satellites are customized for a particular need. So we do not need a very big like SSP all the time to launch a payload in the space. We need small and customized rockets enough. That's why nowadays it's very important to have the SSLV. Maybe I don't know one funny thing. I don't know whether I should comment it or not. Maybe in next 30 years, every person they will have their own satellite. For example, I want to talk to you. I will have okay. I will have a satellite for that. Just and if I want to talk to him, I will have another. And just this scenario, this sounds funny. Mone have power and but this is the scenario is going in this direction. That we want to have a small customized satellite 200 kilometers up, but they are only 30 miles and they don't care about you. And you will be egoistic, you will say, okay, I will send my satellite. Then she will say, I will send my satellite, and we will be full of garbage and we will go to the exchange. Okay. So now, but for different kinds of satellites, nowadays, if for a very growing demand is there for aerospace engineers who are actually, please look at this, who are actually do the designing of the spacecraft or launch vehicles and they design the various components. And they can, ISRO nowadays, they are taking a lot, not only ISRO, there are a lot of private space organizations in India, they are taking a lot of aerospace engineers. They actually not only design this customized satellites, but they also contribute that how small, how cost effective things can be designed. So there is a lot of opportunities that are coming. Now coming back to this is I'm not going to detail, this is Chandrayan 1, which should be very, very proud. Students, I don't know whether you know this or not. Chandrayan 1, not only any NASA satellite, Chandrayan 1 was the first lunar mission who discovered the trace of water on the southern pole of the moon. And remember, at least dozens and dozens of NASA satellites were there with higher technology, but they did not find it. And you know that every time nowadays people are where people are going? People are going to the southern region of the moon. But what the NASA mission therefore is actually in the northern region of the moon. Now it is in the southern region of the moon. Why? Biggest question is why? Why did after Chandrayan 1 discovered the water? So if there is water, there is possibility for further exploration. But one thing I mentioned, this is not usable water. This is in the frozen form, which is frozen at least for billions of years. And to take them back in usable form is another technology which is yet to be discovered. This is the Mars Orbital mission. One thing you know about it, but only mission is that this is happened at a 450 crore rupees because of budget. So one question, I am not going to detail, but I will raise another point, is that if you ask me that a very frank question, okay, student, is the space technology of ISRO and the space technology that NASA and ESA and JAXA are the technologies comparable? Are they in the same generation of technology using or not? Do you understand my question? Answer is no. NASA, ESA, JAXA, they are at least 50 years ahead of us in terms of technology. And there is no question of comparison. That is fact. But what is important is the budget. If similar mission is done by NASA, they will have at least 10,000 crore rupees budget. But we are doing it for 450 crores. So what is the basic idea is that the countries, the small countries have much weaker economy. They are thinking of taking up their own space programs. Okay, because it doesn't depend on NASA, doesn't depend on anybody else. But a small country, they are planning to have their own space programs. So who is the inspiration? Just ask yourself, who is the inspiration? Inspiration is our India, not NASA. Because NASA's technology, they cannot manage because they cannot manage the budget at all. Only after India they started thinking. So then in that sense, India is far ahead than any other country. That is the very important. Now, you know that Chandrayan 2, and it was popularly said that Chandrayan was failed. But remember, we have to remember, only the lander module was failed. Chandrayan's orbital module is not only verifying, but it is also helped the Chandrayan 3. And that's why the Chandrayan, they did not have orbital module, they call it the propulsion module. That's the change the name. And that is, look at the picture, that is the picture of failure. Failure means they actually just 2-3 kilometers above the surface, lunar surface, they actually lost contact and they have some problem. So just in this context, I want to mention about the role of space mission scientists, who actually say that what is their job? The job is planning, management, execution of the space missions. The space mission specialists, they do not build up rockets, they do not build up satellites. They actually plan, manage, and execution of the satellites. So that's why I should mention it in this manner. So if you are expert in this kind of field, there will be no lack of job, good job, lucrative job. You understand? So if you have expertise in this, it is basic because very much after the so-called failure of Mangalyaan 2, this is the real. Okay? So that not only listen to this subject, you can think of taking up this subject whatever expertise you have. You don't have to come to physics, chemistry, mathematics, and computer science all the time. That is the main essence of my presentation. So these are the what advancements in large Mangalyaan. I'm not going much detail, but all of you know this. Look at just to mention one important thing. This is the rope plant is moving around, and it is a taking plant. Can you see that? So why it is important? What is the difference between Chandrayan 2 and 3? Is that Chandrayan rover is taking the decision of turning and finding out a better path to travel. It was automatic, and it was driven by artificial. And nobody from Deep Space Network in Bangalore or ISRO, they are saying, okay, some problem, so they put some command to turn it around. Such things were not done. They are taking decisions and all the paths they have chosen to travel. Look at the path. This path, this actually, and this is the top view of the south pole of the moon. This is not a matter of joke. This is really problematic place. But they have chosen the path, they have traveled by themselves. That is the main thing. And not only that, they have took up a few important things. They found sulfur on the lunar surface, and they measured a very small amount of earthquake over there. Not earthquake, because earthquake should not be so obvious in lunar surface as in Earth surface. Because why you have earthquake? Yesterday you felt earthquake. Why it happens? Because we have in a lithosphere we have tectonic plate structure. We are sitting on the combination of tectonic plates. And tectonic plates are actually floating on the fluid, heated up fluid. So they can move around. They are actually moving few centimeters per year. But moon doesn't have tectonic plates. Even then they have felt something. So people are trying to find out the answer. So answer can be given by only this kind of planetary scientists. So I was just mentioning the different aspects to contribute to the space science. So this is called a planetary. What will they do? They will not manage, they will not execute the space, but they will be studying the geological, compositional, atmospheric structure of these things. And there who are having geologists, biologists, space scientists, even including the specific branches of physics and chemistry, they can do it. So different part of space mission is executed by different type of scientists or people having completely different qualities. So that is what I want to say. That when who are so as I mentioned that there is a lunar quake, not similar to earthquake. Who is actually analyzing the data? Who is trying to find out what happened over there? Not any space mission or space aerospace engineer. They are done by these planetary scientists having this kind of things. They are not involved in when taking up to the moon. When they have started working, when they get the data out. Okay, so now let us move further. This is our ISRO has made all the Aditya L1 data public domain for doing research. For example, just colleges like yours or research organizations like us, any of them, they can download data. You don't have to pay for it. Okay? And they can, if you want to do college projects, if you want to do university projects, you can download data. At least, and there are softwares, and also they will provide the basic training on the software, how to use it and how to. This is not a platform to describe the software, but these are available. You can do it. You don't have to pay. Your college doesn't have to pay for this. These are available. So students, so what is interesting, you know that you don't have to do research. Just get the data, plot it, and try to have fun. That this data is taken one Lagrange point away from you, and this is given to you by your government, by this organization for free. So be proud of that, because they have spent millions of dollars to obtain this data, and they are giving it for free and just for your project. So please utilize this. So we are in this era nowadays. So don't forget about what you used to do, your ancestors used to do. You are in this era, you can do this for this thing for free. Just what you have to do, you have to pay your attention, you have to pay your time, you have to pay your intelligence, or you have to pay your dedication. That is the point. However, so it is after Rakesh Sharma, it was Subanshu, 41 years, and it's a very proud moment last year, 2025, when the Axiom 4, again, Axiom 4 is, this mission was private. Axiom 4 is the Axiom Space, the private company, SpaceX is the private launch vehicle, and all this, and they, of course, they collaborated with NASA and all that, but it is talked about a private thing was happening. And also, Subanshu went there as a part of the private team. Okay. So now what happened? That this is the thing. Subanshu was there as in collaboration with NASA and SpaceX and Axiom. So SpaceX as well is completely private profit-making company. They are doing it now for testing, later they will do for completely commercial purpose. But however, everybody's objective have something to do with the advancement of space science and space technology. So these are the very images there. One thing I want to mention is that this is the Falcon 9 module where it was traveling after detaching from the rocket. But what is important is the reusability. Whether you understand or not, it is very important that nowadays, recent latest exam is not important to go to space station. People can go there, but the main issue is reusability. What is reusability? This Falcon 9 was, when Subanshu was going there, Falcon 9 was, so far I remember, it was used for a second or third time. But before that, whatever technologies were available, one module went there, came back, finished, go to scrap. So that is a matter of huge project. It will cut the budget down to at least maybe 1/3 or 1/4 level. You don't have to make it up. You just get it back, you repair and send it out. So that is the main important. Other technological things are not going there. But what is important is usability, because money matters. Okay, because it is huge. If it is a matter of huge budget, our Indian government would have not interested in space project. Only because there can be done in the cheapest possible way, in our mind. And one thing I remember that all the things, whatever India mostly, so today we are being proud of, mostly they are not importing technologies from anybody else. Or Indian things, they are actually their own mind and using their technology. Okay, so these are some beautiful pictures about working in the space. Many of you have seen these pictures, and they happy moments and walking moments in within the International Space Station. And now this is very important that Subanshu will work on many things. For example, how the microgravity can work, how this microalgae, small photosynthesis can be done over there or not, how the cyanobacteria work, all these things, and what a video we are looking at in the background. This is not only like a happy photo session. This is also a microgravity experiment as well. Not only like all the what they are showing is that all the orientation they are moving around, all are equal. So if I am upside down, I am equally fine. So that is not only a photo session, it is a kind of facility. So this It's happening. Okay. So now this is the picture I'm going to fast. This is a real video which is available from space station, and I'm very proud to say that in 10th of December last year, Sumansu came. And he was there, he was presenting, and he was just describing how he started, how he learned walking for the second time after coming back. That is the demonstrating, and I'm very happy to talk to him and at least have a selfie with him. Thank you. So, I'm not going to details. This is the Mangalyaan, which is maybe will be happening next year. This thing, next thing I will just show you is very quick thing. This is, do you know who she is? He or she. Actually, he is not he or he is not she. His name is hard name, or his is equal fine. His hard name is Mitra. His AI enabled robot. He is actually going for Mangalyaan 1. And he will go there, he will take all the data and again, when on Mangalyaan 2, when Sumansu and their team will go, she will accompany. And she will, every time she will guide that, okay, do this or don't do this. So this is everything she will do. That is not only, take the okay. So neither mission, I am not going to detail, but one thing I should mention is neither mission. Neither is the first mission with NASA ISRO collaboration. NASA actually approved ISRO for our Indian technology. Again, this is the quality of picture. This is the picture of Godavari Delta, Godavari River Delta, and this is the of their delta, and they have like the forest and agriculture fields. So this is just I kept a low resolution image. In principle, very high resolution image, where you can actually look at every square inch very carefully. Okay. So now just to mention that these are again the data science. You know, all of you are aware of machine learning and artificial intelligence. So this kind of data, you are having the data that is not possible to analyze manually. If you are expert in data science, if you can handle large, you know that big data analysis is one of the hottest subject nowadays. These are the applications. It's neither data and the applications in this field. So if you are not at all interested in physics chemistry, if you are interested in artificial intelligence and machine learning, space science is yours. Okay, so this is Shukra mission, okay, and this is the just image of the Indian, and this is called the Aditya L1 station. It is going to be launched in 2035. Our own space station, Indian. That actually secretly the work has been started. Modules are being prepared. It is underway. And for that, you know that another field which is called the satellite system engineer. Those are nowadays very important. They are what is the role of designing and developing and maintaining communication satellites, remote sensing satellites, navigation satellites, as well as to build up the components of the space station. So these people are nowadays very much. If you have expertise, if you have a BE or BA or diploma in this kind of things, for telecommunication, electronics, so the field is yours. Okay. So now I am not going to detail that. What this application is the art, observation, platform, navy, disaster management, strategic things. These are the main parts of space. And this again, for this is the NLS, is the National Large Solar Telescope and the National Large Optical Infrared Telescope and Himalayan Thunder Telescope. Few weeks back in our union budget, these funds were sanctioned. This will build up in next 10 years. So if you are interested in any of the field, if you are trying to be an optical scientist, optical astronomer in future, you are in a golden time. So this is going to be there already budget is allocated in this budget by Honorable Dept. The budget was it will be commissioned in next 10 years. So what is important is that look at this sentence. The number of missions should be doubled in next 10 years. That is India's mission. Whatever number of missions happened in last 10 years, next 10 years number should be doubled. that is the motto of Indian government nowadays. For students, this is the that there is one important competition called International Olympiad on Astronomy and Astrophysics. And in 2025, I don't know whether you are aware of that, India was the champion in 2025. Okay, these are who are champions on technologies are there. These are like of your age, like your friends, maybe younger than you. Okay, so we are in the golden era overall altogether of this kind. Okay, and okay, the private sector into this. This is another very pride moment. This is the first suborbital satellite launched by private. This is called a Skyroot Aerospace. There is private company, not by ISRO. Private have launched this 2-3 years back. So ISRO is not the organization who is going to hire you, who is going to give you a job. These kinds of companies are coming up. And another thing is space tourism. But I don't want to mention because space tourism is a reality. But for nowadays, you have to pay ₹500,000 rupees for one single seat. Without any astronomical, if your pocket is enough to reach, then you can at least travel up and at least for a couple of hours. A happy moment, and you can take pictures, and you can put up the Facebook and clap. But this is the future, one of the future most profitable business is coming. Next, this is our advertisement, our honorable director, Dr. Chandrayan, and his inspiration, all of we are doing things. These are the research, I am not going into details. This is important, certificate courses we have. Okay, if you have, apart from your regular PG degree, if you want to do certificate courses, if you can become, we can have classes in weekend, anywhere, and you can have it online. If you don't want to come and have it, want to have it in home, it's fine. So next is our 1, 2, 3 sessions are completed, 4th session is going to start. Next is 2 courses I mentioned. First course is we call the gateway to the universe. For example, if you don't know anything about astronomy, but want to have a glimpse of it, this is the course for you. If you have some advancement, we call it the astronomy and astrophysics, the language of the cosmos, that can be done. And other specialized courses are there, like this is our observatory. I invite you all of you through Engineering Madam and all of you, please come up. We have our telescope, which is largest in Eastern India, which is actually the largest in Eastern India robotic telescope. So the sky, what you can see, what you can experience, I guarantee you that you will experience it never before. So today, you can see these are the students of Bethune College, and my wife put them there, and a lot of them students regularly they come, they have lectures, they are learned how to do things, they are happy photographs of course, and then they come. So this is a picture of the crater of the moon taken with our telescope, and not much with heavy devices. These are taken with a smartphone. So this is the quality of the picture. This is the quality of the planets and our moon. And this is one last year. You know the Samudra Shikha Mission telescope making workshop. 400 students came. 12-day workshop. They came and they have government sponsored entirely. They came. They tried. They learned how to develop telescopes, how to see sky, and they put the back of the telescope and went back. So this was there. Now this is again Rakesh Sharma was there. Rakesh Sharma actually inaugurated our museum in 2023. Again, I was fortunate to have a very good conversation with him. My good luck, and this is the thing. So last slide. That if you want like you have the replica of Apollo mission and the original writings and signatures of Armstrong and Yuri Gagarin, Telescope, Meghnad Saha, Solten Bose, Stephen Hawking, C.V. Raman, science day today, C.V. Raman, and who is not there? So lot of things. So if you don't come, you miss it. That is my last statement. Oh, you are there?
Yes, one of students. I was there, she was there, and
Oh,
many of our students were
that's
there.
great. So I him, lot of students, I think you also were there in Shuvan's program. I don't know.
Yes, because after that probably yesterday, when simple. Maybe probably around that time also some others because we also have astronomy class. So some of them were visited.
Okay. So what I insist you that you come again and again, because this is a happy experience for you and just for a small amount of money. Because you know that 100 rupees is entry for the museum, but if they have a huge amount of discount, you team up and go. So it is an opportunity. So our objective, our objective is entirely to make the students space science aware. That is the main idea. And that is when somebody invites me, I immediately come up just because I want to reach to them, or our institute, not myself, sorry, our institution, our director, they reach to them so that you know about it, you come, you learn, you enjoy, be happy. And just think that this is not a learning, this can be one of the golden opportunities for a career. Okay? Because many of them, almost when I meet students, and not sorry, their parents, they say that my child is interested in this subject. But somewhere in the middle, they lost their way and they go to different directions. So they come up and learn and be happy. So that's it. Thanks from the College Authority team for having me and teaching all the having all the trouble having me here. Thank you. If you have any questions, I can answer.
So they can mail you yeah. This or some query, then ask.
You can email me, you can take my number, but don't call me. You bring WhatsApp, I will answer. Because every time I don't receive call, we are a lot of things. Because we are our institution, we are like multitasking people. We are not taking lecture.
Guiding missile development program. His contributions, we know him as the missile man of India, and he was the
And why is it? Another term that is related is where is the phenomenon? The answer to this question lies in the sphere of geography. That why Mother is only located in the north part and why the cycle.
Every time I run around, so all these multitasking things are going on. So if you can take my number also, you can WhatsApp me, I will take that. But call I may not do. Okay, thank you so much.